Welcome to this computational design exercise. In it, we'll explore how to create technical drawings from a parametric facade design using Rhino and Grasshopper. In this lesson, you'll learn how to design a dynamic facade panel system where each panel varies in size, thickness and color, all driven by data. More importantly, you'll discover how to automate the entire process, from generating the panels to organizing and labeling them for fabrication, so you can stay focused on design instead of manual repetitive tasks. Now, why is this important? If you've ever had to create construction drawings or prepare models for CNC milling, you know how overwhelming it can get. Managing hundreds of unique panels, keeping track of sizes, colors and material properties, and ensuring your drawings stay updated with design changes can feel like a nightmare when done manually. But that's where Grasshopper shines. We'll use parametric tools to streamline the entire workflow, automatically assigning properties, generating clean technical drawings and even preparing files for laser cutting. This approach not only saves you hours of tedious work, but also ensures accuracy and consistency across your project. By the end of this exercise, you'll have a complete parametric system that updates instantly when you tweak the design, giving you full control and flexibility. So, grab your Rhino 8, open Grasshopper and let's dive in.
Welcome everyone. Let's take a look at some of these examples that I've set up for you guys for different facades, because I want to show you why learning computational design for facade panels is worth your time. So if you've ever tried to, manage a large set of panels and order them according to their color, their shape, as you can see in some of these examples here, you know how hard it can be. So imagine dealing with hundreds of different shapes, colors and sizes, and I know it can feel overwhelming. You have to assign each panel to the right layer, keep track of the materials, their shape, their size, and then produce accurate drawings, right? For instance, here, we've got a lot of examples there where that's the case. And, doing it all manually takes forever, right? But now, imagine a better way. There's a new way with Rhino and Grasshopper in the newest tools in Rhino 8, and we can automate all these tasks. We can attach attributes directly to geometry, like what layer we want to put it on, its material, its color, and a lot of other attributes as well. And we can bake these panels with all their data already included. So this means that if you change one detail, like the size or the color of the panel, everything updates automatically. You press a button and the entire set of facade elements reorganize itself. So I hope you don't have to spend hours redoing your work if you just want to, change a small detail. And that's exactly what we're going to explore in these coming exercises. And the one I picked from these examples here, the one I think is the nicest or the most interesting one is this one. It's a simple facade system that kind of has a gradient. It has different shapes and sizes. So their length and their thickness is different. And as well, the color, there's a gradient that slowly slopes up on the facade. So that is the example we're going to take a look in. So let's get started. I set up a quick definition for you guys to follow along. It already has two things included. One is a Python component that I wrote, which is going to generate for us our tile surfaces based on an input surface, and some colors that loosely resemble the facade I showed you previously, which we're going to try to recreate. So we also don't have to look for colors and set that stuff up. So let's first create our base surface, which is going to be for us right now just a simple plane surface with two domains from 0 to 50. And also, instead of using the XY plane, let's use the XC plane so it resembles a bit better a facade or a part of a facade. The reason I wrote this custom Python component is that we could have used a component from the Launchbox plugin, which is the staggered quads. So let me show you real quick. If I just transpose the surface like this. And, we could have done something like this where we use this component and try to give colors to these panels. The only thing I don't like is that I can't specify the thickness or the length. It's all random. And for the thickness, it's just also one value. And the other thing I don't like is that sometimes the seams, they don't line up. So there's nothing to kind of control that neither. That's the reason why I wrote this component. So what it needs is an input surface and some values. And if you connect this one here, you see that it already ran using these values. So what it did is that if I just start with some more simple values, so instead of having a list of thicknesses, I'm just going to use one thickness for now. Let's use 1.2. And also for the length, let's just use 1 for now. And also for the offsets, let's just use no offsets for now. So what it did is that right now I just have a complete facade filled with tiles that are all 0.2 thick and 1 meter in length or 1 unit in length. If you specify multiple values in, for instance, the thickness, it will randomly pick from those values and apply it to the row. So right now we have a couple of different thicknesses, 0.4 and 0.2, but all the lengths are still 1, right? But I can also use multiple for these ones as well. Let's say 0.5, 1.1, and 1.9, something like this. So we have 3 lengths. So you see that, you already get some more diversity in our facade, even though we only have 6 different types of panels. But still, the only thing I don't like is that sometimes the seams, they don't line up. And that's where the fourth value offsets comes into play. And what it does is that it will pick a random offset from this list and it will offset the row like this thing a little bit to the right or to the left. So the seams, to kind of avoid having the seams to line up, right? So right now, supposedly, you have way more diversity in the facade and still only have a couple of different sized panels. So I invite you to play around with this thing. You can increase the length, decrease the length, etc. Or make this one smaller or longer. And these two values, the T-prop and L-prop, are also very helpful. That is, if you want to apply a probability for these values, the lengths and the thicknesses, how much you want them to appear. Because for instance, right now I have 2 values for the thickness, the 0.2 and 0.4, and they both have a 50% probability of appearing. But let's say I want to give a bit more preference to my smaller thickness, let's say the 0.2. So I would make a list with 2 values, percentages, preferably should add up to 1. So right now I'm giving 80% to this value and 20% to this value. So if I insert it here, you see that the 0.4 only has a 20% chance of appearing right now versus the other one. So this is my list of values. Let's apply some color to this thing. And that's where we're going to use these guys for. And I'm going to flatten the list because I'm not concerned with the organization right now. It's organized per row. So every row is a branch, which is really nice. So what do we need? First, I want to get the UV point based on the input surface, because based on that UV point, I know more or less the height and I can apply based on that the color that I want to use. So how are we going to get that UV point? Basically, we're going to get the center point. So if I use the area component and connect it here, the nice thing is besides the area, it's also going to give me the centroid, and that's the one I want to use. Then I'm going to use a surface closest point and use that centroid to kind of evaluate my input surface, which is going to be, for now, our simple plane. But later on, you can use your own surface like this. And then I'm going to deconstruct that point and the Y. That's the one I'm concerned with. We turn everything off. Because I can get the bounds and then I can get can remap these numbers. So I've remapped them between these bounds, and now from 0 to 1. And based on that new domain, I can divide a domain also from 0 to 1, which I have just remapped these guys as well. So I'm going to get the length of this list because I want to know how many colors are in there. So right now there's 6. So I'm going to divide this domain from 0 to 1 into 6 segments. And then I want to know find domain. So these are my 6 domains. And then these are the numbers basically. Based on these 6 domains, which represent those 6 colors, based on the remap values, it picks in which domain that value lies, based on the y distance basically, or the height. So supposedly if I list item and my list of colors, and then the index like this, if I preview, these are all the colors, and then geometry is our flattened list here, connected here. You see that I have, based on the y value of my UV point, I kind of applied the color to it, right? And the order in which you have put these colors in, that will also determine how they're going to be ordered here. So you might want to maybe reverse this list. So the darkest color is in the bottom and the brightest one is in the top. But as you can see, they have a pretty clean cutoff right now. And I kind of want to have a bit more variation, like a bit more randomness, like we saw in that photo I showed you previously. So to do that, we're going to add a value to the y component with a randomness. So let me just drag this a little bit more to the right. So a summation component like this, and the random components, and a range. So let's say -10 to 10. And how many numbers, that depends on how many surfaces we have. So we can just put this here, get the length. So we have 1338. So we need also that in numbers to add to this guy. Because I still want to get the bounds from this guy, but this one goes in here. Like this. We can delete this one. And instead of the mapped, we're going to use the clipped output. And let's see. So now we have a bit more variation as well. So the trick is just that we added a number to the y output basically, making it appear higher or lower than it actually is, which basically means that, let's say this panel as y value, because I add a random value, it now appears here. It means that it will have this color instead of the one here. That's basically what this component does. It's like a dirty way to kind of add some randomness to it. And you can play around with these numbers as well. Like the lower I go here, you see that most of them get shifted up because the dark blue almost nothing, and vice versa, right? Like right now I almost have no dark blue, but I have a lot of the top one. Depends how much you want to mix between the gradient. And let me also directly get a list of those colors as well. We use a color component, and let me see, these are all the colors. When we're going to bake this geometry in Rhino, we're going to directly add those attributes as well. So now we have the colors nicely assigned to all the individual tiles. So I'm gonna copy this one and link it in. So that's one value that we can add. And some other values that I wanna include when we're going to bake this stuff to Rhino is, first of all, its data branch structure. So the way it's nicely organized right now in 98 branches, with in every branch all the tiles nicely in a row. So that's one item. And the other one I want to add is the unique tag, an ID tag for every panel, because later on we're going to lay out these tiles for construction drawings and maybe even for CNC milling, for laser cutting. Having a unique ID per tile, we can nicely look up all the attributes from a tile. So if you know the unique ID, we can look up its color, its size, its row, its column, all these things. Let's do that too. And we're going to take a look finally into this new tab from Rhino, which is now included in Rhino 8. And all these components you see here in the Rhino tab, they all let you interact directly with the Rhino document. So either geometry that's already located in the document, but also you can add layers, remove layers, change a lot more stuff. And the component that lets us do that is this one, basically, model object. And here's where we can, when we start baking this stuff to Rhino, we can include all these attributes I've been talking about. So this is the component that does that, combined with this one. And this one, basically, if I hit this button here, it will bake it to the Rhino document, just like this. So first, let's set up our key value pairs or our attributes we want to insert into that geometry that we're going to, when we're going to bake it. So the color we already have. Let's work on creating that unique ID tag I said. For that, we need the tree statistics. So we nicely have all the lengths for all the rows, and we have the total count of the branches. For the columns, I'm going to use a letter from the alphabet, and for the rows, just a number. This one goes in count. So now we have a sequence from A, B, C, D, etc., depending on the length of a row. So those are all our columns. For the rows, I need a series component so we can have like a sequence of numbers. I'm going to use a count input for that. So we have 0 to 97. So we have 98 numbers for all the rows. I just have to duplicate them depending on how many items are there per row. So this data I want to duplicate, and then the number of duplicates is the length. Let me just craft it to be sure. Just like this. So these are all our text, and we can flatten this thing. And then integer, these are all the row numbers. And we can combine these two into a nice unique ID tag. And we're going to use the format component for that. This is a very nice component because it allows you to manipulate a string, a text, with using placeholders. And those placeholders are what you insert here. If you zoom in, you can add more inputs. But for now, we just have two. So we only need the 0 and the 1. Just like this. And for the format, you can use a text. And what you put between curly brackets, that's going to be replaced with the actual text we're inserting in the 0. So right now, curly bracket 0 will be replaced with everything, all the items I insert here. And I'm just going to use a dash in between. And 1 will stand for everything I insert here. But it's the other way around. It's 1, 0. And let me show you what happened with a panel. So now it combined these two outputs together using a dash in between. You can use whatever divider you want, and not use one at all if you want to. Just delete everything like this, and it will just stick exactly the text together. Another thing I'd like to do, as you can see here, there's 98 or 97 rows basically. Because it's a tag, I don't want it to start counting at 0 because it's always a little bit annoying. So I want to start counting at 1 so we directly know what row we are in. So I'm going to use a panel with 1 and just name it start counting at 1 so we remember. And use this here. So now we start counting at 1 and we nicely have 98 rows. And the last thing I want to do, which also allows me the format component to do very nicely, is to add some trailing zeros in the front. So the tag more or less has the same length. It's just like a, aesthetic thing. So we have 98, so basically 2 digits, but we're almost above 100. So we can add 2 trailing zeros in the front. And the way to do that is to change the formatting. So it will be the 1. And then if you add a colon and then define with some zeros how many trailing numbers you want, it will change it like this. So now we have 2 trailing zeros in front. If you go to the decimals places, basically when you have 2 digits, it will, only put 1 in front all the way to, if you have 100 rows. So let's say if we increase the size just a little bit, so we add some extra rows. So now we have 102 rows. You see that there's no trailing zeros in front because we already have 3 digits, right? So this is going to be our ID tag. That's one. And this is just for maybe later on going to order these panels for construction drawings or laser cutting. But I also want to include the branch structure. So because when we start baking it to Rhino, the thing that's not so great is that you lose this organization. And by adding also the attribute of like the branch structure per tile, we can later on, when we link those panels back into Grasshopper, we can retrieve that structure. So that's very nice. So the way to do that is first get that branch structure, which is using a param viewer. These are our surfaces. And I'm going to graft these guys. So every tile right now is in its own branch. And if I connect it to here, the nice thing is that the output from this panel, or the output from this param viewer, it just outputs a text with the branch it's in. And as you can see, these ones are also all unique. So these would be, I'm going to call it data 3. Nice. So these are the attributes I want to add. So this one, I'm going to put this one here. Okay, what else can we include in the panel? We can also include their size. So let's do that as well. So I'm just going to get this one, the flattened list. And I want to get the outline. So if you just connect a curve component to a surface, it will just give you the outline. So that's very nice. And if you explode those curves, we get the individual line segments. And if I list item to see which segment is what. Okay, so the first one is the height or the thickness. The next one is its length. I can get length for both. What we can also do is, let's round these guys a little bit. Just in case, because sometimes if a panel is close to the edge, it might get a weird cutoff and has a weird, like a really long decimal place rounding. So now we just round to 3 decimals, so that doesn't happen. So we have the thickness and the length, and let's use the format again, so we can combine them into a size. So I'm just gonna flatten this guy, flatten this guy. Instead of a dash, I'm gonna use the X. Let's just flip them around. So we first have the thickness. Yeah, so it's 0.2 by 0.8, 1.8, 0.2 by 1.1, etc. That's nice. And if you want to, you can also put trailing zeros here if you want them to have all the more or less the same length, but I think for now that's fine. That's also a text. So this would be size. I think for now we have enough attributes that we can add to when we start baking. It's called a key value pair, where the key is basically a description. So it can be size, color, ID tag, or whatever you want. And then there's a value that's always linked with that key. And that is the actual value that we're going to bake. So for instance, we have color, and then we have all these lists of values. So we need to create the list of keys as well. So I'm just going to use a panel and specify size. What we have color, we have ID tag, and then we have data tree. The trick is just to copy it the amount of times these guys also exist. You can do that using a duplicate component. So duplicate data, the data you want to duplicate, and the number of duplicates, we're going to get that one from here. And it's important to set the order to true, so it keeps the order, so it copies size, color, ID tag, data tree, and then it repeats it again. If I set this thing to false, it will first copy size this amount of times, then color, then etc. until it runs out, but I don't want that, so make sure this one is set to true. And then we just have to partition this list so it has the same data structure as these guys. I mean for later, which is this one. So now we have basically per panel these 4 values or keys, and they're all the same. And now the only thing missing is to have to get these ones in the same data structure as these guys. And a nice way to do this is using the entwine component, because this component doesn't care if it's already flattened or not. It will just remove it and put it in these nice branches. And if you flip this result, we have the same data structure as here. That's correct? Yeah, that's really nice. Okay, so now we have these guys and we have these guys, and the way to add them is using this component here, a user text. The keys go in here and the values go in here, and content, that's going to be the output from these guys. And then the content goes in here. The nice thing is I can bake it now and just include the key values, but I want to add a little bit more. I also want to add a layer to which we're going to bake these guys. And I also want to include some materials in Rhino so we can directly preview how the colors turn out and etc. These kind of things. So for layer, that's the first one we're going to do. We need to create that layer, and that component's located here. If you zoom in, you can expand this one, so you have all the options. There's literally anything right now you can change from the Rhino document, which is it's very helpful. The name, if it's hidden, if it's locked, display color, all these kind of things. But for now, I just want to create a layer with a name, so I'm just gonna create a layer called panels. And the layer right now is created, so this one goes into layer. It turns orange because I haven't inserted the objects yet. That would be these guys. But I have to craft it so, or maybe here better. Yeah, let's see. it's better if you put it in the geometry inputs, and then it will turn it into a Rhino object. Nice. And graft it with all the keys. Yeah. Okay, so now we have included as well the layer. The only thing missing here is render, and that's where we're going to insert the render attributes, and those include the materials, so all the colors basically. So we have to construct a render material, which is this one, render attributes, and object material. That's the one we want to have. And those are the colors, which are these guys. So one goes in here, and that didn't work. We have to construct that color. Let's see. Let's render material. This one goes in here. I think it's already like this directly because it set it automatically to by object material. So this one goes in here like this. So now we have set up everything. So supposedly, just let me turn off the preview. If I hit this button here, push content, it will bake it to Rhino. I just did that, as you can see. So let's see if it worked out. Cross our fingers. Okay, so at least it baked it to the right layer called panels. Let's select the panel. So let's say this one. And if you select a Rhino object and you go to its properties here, and you go here all the way to the right, called attribute user text. Right now we see that it correctly put those colors to it. I mean those all those key values. So we have the size, we have the ID tag, we have the data tree, and the color. And depending on what you select, it will update those. So that's very nice. Let's see if the color also worked. Yeah. So as you can see here now, it also had the correct material applied to it. And the cool thing is that if let's say if I change my settings, let's say, I know I'm going to create a little bit of a bigger wall, or I'm going to change the dimension a little bit. I'm also going to change these guys maybe a little bit. I have a completely different wall. The nice thing is that this component will remember it. So if I hit again push content, it will delete all the previous ones and update it with the most recent ones. So you don't have to first delete it and then have to remember, hey, what are they already baking Grasshopper? What I have to delete? So you don't have overlapping geometry and things like that. That's a very powerful way of dealing with geometry directly in Rhino using these new components from the new Rhino toolbar in Grasshopper, that it remembers all these things, right? And we've just touched the tip of the iceberg because like I said, you can change so much things here. Like you can also include a line type, a material, I mean, all these things, right? All right, so now that we've baked our geometry to Rhino with those attributed included in the geometry, let me show you how to link back that geometry back into Grasshopper and retrieve those attributes. So let's start on a new line, because let's say you don't have this definition. You just got this file from someone, from a colleague. Let me show you how you then can use these attributes that are now baked inside of these, like all these styles, by going to properties and, you know, the user text. Like here we have all these key value pairs, right? So if we go back to Grasshopper, and if you go to our Rhino tab, and then in the model, the subcategory, under objects, query model objects, that's the one you want, because we want to query all the objects that are in the model. And the nice thing is here, it will by default retrieve all the objects in your Grasshopper viewport or in your Rhino viewport. But if you want, you can filter by name, by layer, by group, etc. So in our case, because we've baked our geometry to the panels layer, we can filter by that. We've now retrieved our components, which are in the the layers panel. And the nice thing is that I think if I list item just to see what order they're in, yeah, the thing is that they're still ordered nicely, like in order. So the first row all the way to the end, and the second row and the third row. But let's say if I just scramble this list a little bit. So now we have here our first element is all the way up there, right? And the second one is there, the second one is there. And that's where the those key value pairs come in handy, because that may be the case if you link it in from a document that someone else passed you, like a Rhino file. So the way to retrieve those key value pairs is to go to content and again user text. This component lets you either modify or retrieve those key value pairs. So this is the content. And then under the keys, we have all our keys. So those 4 ones that we inserted. And then the values, those are their corresponding values. And the one I'm going to use now is the third item, or the fourth, is the data tree structure, because those items I'm going to use to kind of reorder my my list to again get that data tree structure. Because it's always going to be the third item, I could just list these items, but a more consistent way is to use find member, which is under the sets tab, and then sets and find similar member. And the key that I want to look for is data tree, because that's how I called it. So let me see. So these are the keys. So what it is that from those keys, it will look if it can find this text, and then it will return the closest one that it finds, but also the index. So it retrieved, hey, this item is located index 3. And now I can use that index to retrieve my value. It's just, this way is more consistent, because if I would say switch these ones around, let's say instead of inserting it all the way in the end, I insert it somewhere in the middle, the index would change. So I would have to change this one as well. But right now, it will always retrieve the correct item. And the nice thing is that I can use this component, replace path, to kind of reorder the original data structure. These are my tiles, just like this. So I'm going to graph them so they're all under each in their own branch. I'm going to use the param viewer to get those branch names. It goes in here, the ones I want to search for, all these. And then the ones I want to replace them with, those are the outputs from these guys. So this one goes in here. And that's it. So right now, we have all our tiles again back into that data structure, right? So that's really nice. But I think we have to shift them back so they're not all in their own branch, but per row. And now if I list item again, I should get all the first tiles from a row, which is now, as you can see, the case. So that's really nice. Another thing that we can do is what I was thinking. Let's say you want to send this part of the facade to a manufacturer or something like that. You might want to sort the tiles based on those attributes that we included, right? It could be based on the size or the color. So let's first sort them by their color, right? Then again, here's where the key value pairs come in handy, because under the Rhino tab and then under content, there's all these components to filter the content, which is this one. And that's the one we're going to use to filter out that content even further, because this part just orders it, what we just did. And now we're going to filter them using this component. And for the filter, if you go to your params tab and then in the Rhino and then model attribute key, that's the one I want to use. And then here, if you right click on that component, you have this window here, and here you can pick what kind of attribute key you want to use. And in our case, we want to use user text, and then just make a panel with the user text you want to retrieve. In our case, it's the color key. And this one goes in here. Oh, excuse me. First we have to equal. Because I want to compare this color key to a value, that is going to be the filter. And this one then goes into this one. And for the value, let's retrieve our list of colors that we use. So it's all the way in the beginning. That's right here. It's these guys. And then we can use a list item to just toggle through them. And let me get a legend so we can see directly the color. And this one would go in here. And I think we have to convert them to text, because if not, it's not gonna, because these are, I think, hexadecimals. So we can just convert things to text by using the text component or parameter. So now, as you can see, it did retrieve it. So if I return a color, somehow it can't find it, but converting it to a string somehow did work. So as you can see here right now, I filtered my whole facade just using this color. And I can use like a slider to toggle through all my colors. So that's a very helpful way to just select, the colors that you needed. And the nice thing is that you can combine filters, because let's say not only I want to have the dark blue colors, but also I only want to show tiles that have a certain size, right? So let me copy these and create a key for the size. So it will be size. I want to see, instead of equal, we can do logical and or intersection. I think this one combines multiple together. Equal. So this one would go in here. And then another equal for this one. And then for the value, let's say I want to look for a panel that's 0.2 by 1.8, which is one of the, it's 1.9. So these are all the dimensions we have. So let's say I want to have all the tiles that are 0.2 thick and 1.9 long. So 1.9. Let's see if that one works. So now it combined these two filters together. So let's see. And it worked. Nice. So now, as you can see, all the tiles that are selected are from this color, and they're all, this size. But of course, I can change those things as well. Let's say I want to have all the tiles that are 0.4 by 1.1 or something like that. So you can do 0.4 by 1.1. You only get those guys, right? So it's a very nice way to kind of use geometry that's already in Rhino, if it's baked with those attributes, how to kind of retrieve them and manipulate them and kind of do something with them. So before we start organizing our tiles for laser cutting and construction drawings and things like that, we have to install a plugin for Grasshopper that's going to help us with that. And Rhino right now has a new way of installing plugins either for Rhino or for Grasshopper directly. So you don't have to copy files into your system directory and things like that. And the way to do that is going to Rhino and typing in Package Manager. Because the Package Manager, that's that new tool. And the nice thing is that you have a window that will pop up with a search bar where you can search for a lot of different types of plugins, right? So I'll just advise you to scroll through them. There's a lot of really interesting ones. the one we're going to be using is called OpenNest. So if you type in OpenNest in your search bar, it should appear. So this is the one you want to have. Just select it and hit install, and it should install for you. I've already installed it, but the first time you install it, I think you have to restart Rhino. And when you've done that, just hit OK. And if you go back to Grasshopper or open Grasshopper again, if you go to your params tab, there should have appeared a new subcategory called OpenNest 2. And those are the components we're going to be using. So the first thing we're going to be doing is lay out all our tiles we're going to be wanting to prepare for laser cutting, right? So let's say, again, instead of doing all the tiles at once, I think it's wise to maybe sort them by color. So right now I've selected the first color, the dark blue. So let's start with those guys, which are these. And the component first we're going to be using is pack objects. And this component will lay all these objects in rows. So we need to get a plane as well. So let's just get evaluate surface. And let's just pick the corner point, so the 0, 0. And use the frame as a plane. Go in here. And these go in here. And the nice thing is that because we reordered again instead of having just a simple list, we used the data tree key to reorder our list into the data structure it had. And because it's still organized by rows, this component will take that into account and will basically lay out per row all the tiles with a spacing X and Y. So it's very helpful, right? The only thing I want to do is, because we have a lot of empty branches, if I can show you, because of course not all surfaces were retrieved. If you scroll all the way down, because there's no dark blue color in the top of the facade, all those branches are empty. So I'm going to clean those out, because this component takes those empty branches into account, so it can give some troubles, right? So we need to set remove empty branches to true as well. The other ones are already set to true. Let me just use a toggle so it's a bit more clear. Just like this, right? So now I can toggle through my colors, as you can see here, and we get, we get all those per color, we get them nicely laid out per row. But that's not all we can do. We can even include per tile their key value pairs. I think that's also very helpful to have like per tile knowing exactly, hey, oh, it's this size, it's located in this row and in this column. So you know the location in the facade where it's located, plus their size and their color and their ID tag even. Let's see if we can construct that too. So let's get again our keys. So let's go to our Rhino tab and content and user text. These are the ones, because these are the cleaned ones. So from these ones and content. So I'm going to use again the format component to format these guys next to each other. So I'm just going to use first the key and then just a colon with a space and then, their value. So supposedly, if I use panel, I just stick them together using a colon space between. So I think that's nice. So what I want to do is include this information like right next to the panel. That's the goal. Instead of having them all their individual items, I just want to have one item. So I'm going to join this text with an enters in between. So there's a nice component called text join, which I can use. And if I use a panel and just use an enter as the join character, it just combined everything into one item, but with enters basically between the text instead of having them all being their own item in the list. Now comes the fun part a little, because we're gonna create a text object that we can then bake into Rhino. So we need to go again to the Rhino tab, and like I mentioned, there's so much stuff you can do. Like besides layers and geometry, you can also mess around with things for drafting, like the annotations, which there's a lot of different options you can do. So we're going to be creating a text entity. So the text would be these guys. And the plane, that's for later, because first we also need the text settings to determine the height and everything. And also we need annotation style overrides, if I'm not mistaken. Let's see, because these are for later. Let's first see how it turns out. So result, these guys, for the plane, we can use again the same frame we used for these guys. So let's see how the branch structure is. We need to graph these guys. And then we can use the transformation output. So you have geometry, which are the panels. And then there's a component called transform, which lets you transform a geometry using transformation information, which is exactly these guys. So the geometry that I want to transform using the same, like the way these tiles were laid out in Rhino, this is the information through which they were transformed. So I'm going to use the input for that guy, for those guys. And I have to graft it. And then these are the ones I want to transform with it. So as you can see, it nicely put all the text entities per tile, right? And the only thing, as you can see, is that the formatting is a bit off. I want to scale them a little bit and position them a bit better. And that's where these guys come in. So let's see. First is the text height. So I'm just going to use a slider for that. I'll set it to 3 for now. And the horizontal and vertical alignment. So those are integers from 0 to 3, I think. Well, we just have to play around a little bit and see how it works. So those are the text settings. And then just the annotation. This component basically lets you adjust or override some annotation style, which is the text entity. So that's the one I want to adjust a little bit. Using these text settings. So let's see. So you already saw it got nicely repositioned. The only thing is it's still too big. And that's where the model and layout scale come into play. Let's see, because I want to first get all the styles from the document. Let me see. Query annotation styles. So we can directly apply a style to it. So let's just use the first one. It's just the default one, the meters architectural. So let me pick the first item, that one. So models style, like this. And then model scale, that's the one that's gonna allow me to adjust the scale. It's better to use that one and not the height. So depending if you're a model scale or in the layout scale, it will still keep the same size. I think 0.01 maybe. Let's see how tiny it is. I mean, just like this. Nice. So now we have, if I group these guys, we have our geometry and like information in the corner point per tile available. So I directly know, hey, this style is this size, this color, and it's located in the 4th row in the column C. And I can bake these things, and supposedly, yeah, it stays the same, the size. So that's very nice. And again, everything is set up parametrically, so I can toggle through the colors and, you know, get the list and everything. You might wonder like, hey, why is there only one tile in this row? It's because that's the only color. In row 31, there's only one tile with this color present, right? So, and we can even verify that if I turn on my panels. Let's go to rendered view so we can see the colors. So let's see, it's row 31. It's this one probably. Yeah, 31A, which makes sense because in this row, it is the only one which is there. So supposedly it should also be in column A. Let's see if that's correct. Yeah, 31A, which is precisely this one. All right, let's continue with the last part of our exercise, which is laying these tiles out on sheets for laser cutting. And for that, I'm going to start on a new line. So let me just go here, copy these guys, and move them here. And I'm going to flatten the list. Okay, so what do we need for preparing these tiles for construction drawings, for laser cutting? Again, we're going to use a component from the OpenNest toolbar. And this time we're going to use the main component called OpenNest 2, which is used for nesting our geometry. So what do we need to prepare as inputs for this component? First is the sheet, which is the size of your sheet you're willing to use to order your tiles on. So that's going to be for now a simple rectangle. So let's set that up. Simple rectangle, and let's use 2 domains as the input. And let's use a sheet from 1.2 meters by 2.4, which is a standard size for sheeting. Like this. So just a simple rectangle. So let me just prepare these. So we have geometry, which are going to go in geometry. And then we have a curve going to be our sheet, which is this guy. Just going to put this input geometry. This is going to be the sheet. And then the last thing I want to also put is the attribute, which is going to be our ID tag. So I'm just going to put a data component, call this ID tag. Okay, so before we can insert this rectangle directly in sheets, you have to convert it to a sheet, like a special geometry type that OpenNest uses. And that is this component here, sheets. And if you insert it, it will come already with some inputs. That's very nice. And for now, let's keep these at its default. So we have, it right now makes 20 copies of my sheet. And it's going to lay them out using these distances. We might have to adjust the gap size a little bit. So let's insert this one here. And as you can see in my Rhino document, I just made one big row of sheets. So I'm just going to reduce this one. So we have, 6 per row or 5 per row and then 4 long. Let's also reduce the gap a little bit to 1.5. So they're a bit more closer together. And let's use 50 sheets just in case. So what you want to insert is the polylines are just like the actual geometry that you can see in my Rhino canvas right now. But the ones you want to input into this component is the sheets output. And the next thing we want to insert is the geometry. And we have to do the same thing. we have to prepare that geometry for laser cutting. So if you go to the OpenNest toolbar and the subcategory, this time select geometry. And we're going to only accept polylines, not curves. So we have to convert our outlines to polylines. And a quick way to do that is just connect a curve component to your surfaces, to your tiles, which will directly get its outlines. So that's very nice. And this one goes in here. And simplify, you can leave these ones all at the defaults. Copy one, because we just want one of every element. And we can insert the geometry into geometry here. Let me also turn these guys off. And then the last thing I want to do before running this component is add its attribute as well, which we can do here. So besides the geometry for nesting, we can also include attributes, which can be anything. It can be accompanying geometry. It can be like an ID tag, which is the one we're going to include, but much more. So for that, we have to set up a text element like we did before. So we can copy some components from the previous part. It's all of this I'm going to copy. I have to set this all up. And let's disconnect all the inputs. Because the font right now I want to use, instead of the default font, I'm going to use the font. That's a font for laser cutting, which is a single line font. Because for the nesting component, there's an option input. And if you insert that options, it's this one, this options component, it directly comes with some inputs as well, and also the sheet font. And this font, the Maxsoft, is a single line font. So we're going to use this one for the font here. Because I always forget the name, but this way you can just copy this panel. So you have the font here. I would just remove the -10 in the end, because we're going to specify the height ourselves. Just like this. And now we have to set up like what we want to include as the text, and that's going to be just going to be our ID tag. So again, we can retrieve that ID tag from the geometry. Let me just move everything a little bit to the right. Because before I'm going to insert the geometry, I forgot. We're going to lay them all flat on the XY plane. It's not necessary per se, but it's just for us to have a bit more clear how the geometry is going to look like. And also we can more precisely specify a base point. So the way to do that is using the evaluate surface component, this one. So we get the frames again. And then use the orient component. So orient is this one, to kind of lay that geometry flat on the XY plane. So the source would be our frames that we just created. And then target you can leave at default, because it's the XY plane by default. And as you can see here, all those panels, this is the base point, all on the XY plane, all overlapping. So that's very nice. And I think from there we can get the key that we want to retrieve. Just see with a panel what the output is. Didn't retrieve it. Maybe from here. Yeah, that's the thing with Grasshopper, that if you do an operation on a geometry, for instance, here we kind of transform that geometry, we orientate it on the XY plane, it loses its, unfortunately, the key value pair. So it have to retrieve it from the original linked-in geometry. So here we have all the values, and we are going to use the same method as we did here to kind of retrieve the key value pair. So I'm gonna connect this one here, delete this one. So what you saw in the previous lesson, we're gonna use the same method, but instead of data tree, right now I want to retrieve the ID tag. Also here, all the ID tags got retrieved, and those are the one we want to use as the text to put on the panels itself. So let me see. Text is this one, text entity, and the plane. I want to put them in the middle of my panels, of my tiles. So the way to get the middle is, there's a couple of ways, but we can just get the area component, which directly gives me the centroid from these guys. If let's see, we have 228, 228, supposedly. One goes in here. Yeah, so now we have all those text nicely in the center of all those panels. Okay, so let me move this one here a little bit more. And like I mentioned, we're gonna, per curve, per outline, per tile, we're gonna include those attributes. And it says here that if you have attributes, you have to put them all in the same branch as your input outlines. So we're gonna do that. So let's graph these guys. So they're on their own branch. And we have to do the same for the attributes. So you can just graph these guys as well. And the last thing to put is insert the options here. I'm gonna leave the options right now at its default, and let's see how it turns out. And we just have to set the toggle to true. So let's use a toggle here. And for iterations means how many times you want the component to run to kind of find the optimal nesting solution. So its default is set to 1. Let's set it to 5 for now. So we have 5 iterations. And let's set it to true. And you can see in your Rhino command prompt, you see the component running, because it looks like it froze right now, but as you can see here, it ran. So that's very nice. And let me turn off some components so we can see the result a bit better. And here you can see that it laid out all those panels at the correct position, right? So that's very nice. So let me see. So geometry. To get all geometry. Then we get the sheets, which are our sheets. And then the last one is the attributes. So let me also put that one. And as you can see, it's really tiny, so I have to zoom in all the way. So let me increase the text a little bit. So let me set it to false. And let's increase this one to 5, maybe. And let it run again. Nice, so here you see that all of my panels, they nicely got laid out for laser cutting, right? We can adjust a little bit of the settings, because what I don't like is that the text is not really centered. Sometimes it's like orientated or aligned to the left and aligned to the top. So I want it to be middle. That's where these guys come in handy. So horizontal alignment, I want to set that one to center. And vertical alignment, I think also it should be 1 or maybe 2. Let's see how it turns out. Or I think I can maybe even see them before, if I just select the first one. It's this one. And I also get the first center point, which is this guy. So now it's aligned to the bottom. I also don't want that. So maybe 1. So 1 and 3 makes it aligned in the middle. So that's the one I want to use. And also I'm gonna decrease the size a little bit, because the smaller panels, the text doesn't really fit. So let's see. And let's run it again. It laid out all the panels according to the settings. And as you can see, the other thing I don't really like is that they stick together. There's almost no spacing between them. And that is where the options come in handy. For spacing, let's use 0.2 or 0.1 even, maybe 0.05. So we have 5 centimeters of tolerance. It's also stuck to the sheets as well, because now it's going to keep spacing between the tiles themselves, but not to the edge of the sheet. So usually you also want to have a little bit of space there. So the way to remedy that is to offset the sheet before you insert it. With a small number. So let's say also 0.05. So I offsetted the rectangle to the inside. So we used this one instead of the outside one as our sheet. And then when I get the sheets out again, I offset it back. Let's see, offset curve. And distance is the same value as we used here. So this one goes here and then this one here. So we have all the values. And let's run it again. So now we have a nice spacing between all the elements and also from our sheet. So that's very nice. You know, you can decrease the spacing as well, because now we see that we need more sheets than we had before. So you might want to play with these settings that, well, I only need 2 centimeters of tolerance. And maybe here too. And also let's take a look at the options. So the first one is rotations, which is an interesting setting. It's a value that is divided by like 360, the number of degrees. The integer that you insert here, it will divide it by 360. So right now the default is 4, which means that we have 90 degrees. So that means that every element will be rotated 90 degrees and then put the best way possible on the sheet, let's say. But let's say if I do 2, it will only be rotated 180 degrees and 180. So for us, because we have, you know, rectangular panels, 4 is the most useful one, because it's just basically flipping it 90 degrees and flipping it again, and we have all the options basically. But if you have shapes that are more organic, you might want to increase the number of rotations. And then below it is wiggle, which means that in the rotation itself, it can also wiggle a little bit to find like its appropriate place. And then placement type, we have box packing, gravity packing, and squeeze, depending on what gives the best results. Sometimes I get a bit better if I use number 2, the squeezing. The seed value, because it's a random, there's a random component inside, so it has that seed value as well. Simplified tolerance is if you want to simplify like the input geometry as well. And mutation population have to do with the simulation. How many population you want means that the more you have, the more it will try to find the optimal solution. It's a little bit like the Galapagos evolutionary solver. And time, like instead of iterations, you can also use a time. So let's say instead of saying how many iterations you want, I would say, no, I only want it to run for 10 seconds or 20 seconds or whatever number you want. Let's see what happens. These are the construction files that you can send to manufacturer, like, hey, these are all the same colors. And the nice thing is every panel has a tag, so you can keep track of it. And if you don't really know where that tile is located and everything, that's why we did the previous setup. You know, for every tile having the key value pair attached as a certain text. So you can look up the ID tag and know exactly like, it's, you know, this is the size, the color, and where it's located in the facade. So that way you can really quickly switch between your different colors, put another color, and spit out construction drawings fairly quick. I would advise you just to play around a little bit with this. I'm going to clean up the definition a bit. I'm going to put a data dam here in the front. So you can do that right now. Just to avoid that, if you change your inputs, as you saw, it always takes a little bit of time for this thing to run. That you don't accidentally, if you change the value, that you have to wait for the definition to get a solution. One goes here and then in here. Like this. And I'm going to put the same data dam here as well. Data dam, like this one, and this one goes in here. So every time you change the value, it doesn't slow down your definition. So right now you can check the color. You can switch between colors. Let's say like, well, I want to do, lay out this color. You just press play, so the information flows through, and then you set this thing to true, and it should lay out all those panels as well. And these again, you can send to a manufacturer and all things like that. Just to make it consistent, this is my ID tag. Let me just move this a little bit to the right so we know. So that also leads me to the end of this exercise. I hope it was helpful for you. I hope it can be helpful not only with, this silly example with just some colored tiles and everything, but also facades that maybe have different shapes or anything you want, but not being afraid of having different types of elements. Because the whole goal for me was to show you that even though you have a lot of different types of elements using this method, you can keep track of them, keep them organized, and be very quick into generating construction drawings to do other stuff with them. So thanks so much, and I'll see you in the next one.
Thank you so much for following along with this exercise. I hope it gave you a clear idea of how powerful computational design can be when working with parametric facades and technical drawings. Now, if some parts felt a bit challenging, or if you're looking to dive even deeper, we've got you covered. At Think Parametric, we teach computational design step by step, whether you're just starting out or already have experience. But we don't stop there. Our platform also offers courses on BIM, visualization, graphic design and much more, helping you build a well-rounded skill set for modern design and architecture. If you're ready to explore more and take your skills further, check out thinkparametric.com for full courses taught by industry experts. Thanks again for watching, and I'll see you in the next video.